So I want to know the relationship between two different bond prices. And what I'm going to do, let's say I want to compare the relationship between the US 10-year bond, the US Treasury 2-year against versus the US Treasury 10-year bond. Okay. Specifically, I want to know, okay, I want to know if the price of the 10-year, of the 2-year, I want to know if the price of the 2-year US Treasury bond, these are government bonds if you're not sure what I'm working with, but this is a class for business economics, finance, business. I'm assuming you know 2-year, 10-year US Treasury bonds, right? Uh, it's a simple Google search will pull it up if you're unfamiliar with it. But I want to know if the price of the 2-year US Treasury bond is the same as the price of the 10-year US Treasury bond. Okay. All right. So, how would I state that? Right? What's my null and alternative? Right? Step one. Right? Step one. State the null and alternative. Okay. So, what do I want to know? Right? Well, I want to know if the price of the 2-year is the same as the price of the 10-year. Right? If I was doing a one sample hypothesis test, I would probably say, all right, well, I want to know if the price of the 2-year is greater than or equal to $50. Right? That's if I was doing a one sample hypothesis test, right? Remember, a one sample hypothesis test is just when we're comparing the population to a specific value. So, is it greater than $50? Okay. Now I don't care about that. I just want to know the relationship. I don't care if the 2-year treasury bond, I don't care if it's $5, $20, $50, $100. I just want to know if the 2-year treasury bond is the same as the price of the 10-year treasury bond. Okay. So, in other words, I want to know is the average of the, of the 2-year. It's the second time I did that. Is the average of the 2-year the same as the average of the 10-year? Okay. Against the alternative, right? So I just want to know, is the average of the 2-year the same as the average of the 10-year? That's what I want to know. Is it the same? Is it equal to? Is the 2-year the same, the equal to the 10-year? That's all I care about. Against the alternative, mu 2-year. Okay. If it's equal to in the null, if the null is equal to, then the alternative is not equal to. Not equal to 10-year. Okay. So that's all I'm concerned about here. I want to know, is it equal to, not equal to? That means that I have a two-tailed test. Okay. I have a two-tailed test with a positive critical value and a negative critical value. Again, zeros in the middle. Okay. All right. So how do I find this out? How do I find out if the 2-year treasury bond has the same average price as a 10-year treasury bond? All right. Well, step one, state the null and the alternative. Step two, level of significance. I'm going to use 0.05, right? I'm going to make that my level of significance. Step three, choose your test statistic formula. Okay, step four, critical values. Step five, go. All right, well, I mentioned you can do all of this in Microsoft Excel. You can do it by hand and it'll take you, 20, 30 minutes. Sure. But since we have these computers, let's use the software to do it. So this is what I would do, right? I'm going to go, oh, I have to stop screen share here. Right. So I happen to have this financial portfolio. Okay. And in this financial portfolio, which it's a mock one, okay. But in this financial portfolio, I happen to have the prices, US Treasury 2-year. Okay. I have prices of a 2-year Treasury bond, and I have the prices of a 10-year Treasury bond. And you can get all of this right off of the Federal Reserve Economic Database. Okay, if you Google Federal Reserve Economic Database, and then in their search bar, once you go to the website, it's the St. Louis Federal Reserve. Once you go there, go to Fred, and you just type in, price of 2-year Treasury bond. You could probably just get it off Google now. I mean, but any financial based website has this information. Okay, you download it. I just put it into Excel. Okay. So if I want to run a two sample hypothesis test, what I do is I go data analysis. Okay. Just to be clear, in case some of you have Excel, you go file, options, add-ins, Excel add-ins down at the bottom. You click go, and you just want to make sure that analysis toolpack, you want a check mark to be there. Okay. You want to have this check mark. Okay. And you click OK. When you do, right, when you click OK, you click data, and then over here, there's data analysis. Okay, you need to put that check mark there, or else this data analysis thing will not be there. Okay, so you do data analysis. If you have a MacBook, if you have an Apple computer, don't bother. Apple never made this for Excel. Sorry, they just don't. But to be honest with you, it only exists on PCs, and the reason for that is because the business world, for better or worse, right? I'm not the one who did this, but the business world uses PCs. The business world does not use MacBooks. So that might be a consideration, to think about when you buy your next computer or something like that. We don't use Chromebooks. We don't use MacBooks. MacBooks are great for listening to music, editing videos, stuff like that. But it's not for business. It just isn't. Okay. Quantitative analysis, they use PCs. Okay. So we go data analysis. Okay. Um, and then what we do is we go down t-test. Look at this, t-test, paired two sample for means, assuming equal variance, assuming unequal variance. Okay, we always do the third one down. There's also a z-test, but really don't work with that frequently. So two sample assuming unequal variance. We just click OK. And then variable one range. This is saying like, hey, where is the data, right? What's going on here? Tell me what to calculate. So I'm going to calculate the US Treasury 2-year. Okay. So that's for variable one range. For variable two range, I'm going to do the US Treasury 10-year. It's too much. Okay. Hypothesized mean difference. I don't know. It's just asking you if you take one column and subtract the other column, what do you think it's going to be? I don't know. So I just saying 0. Labels. Yes, there is a label in the first row. There is a label. Okay. Alpha. This is where you make alpha, right? Do you want the level of significance to be 0 0.05, 0 0.01? What do you want to be? I'm going to say 0 0.05. Why not? Output range. Where do you want your output? Right. So I'm going to click in the box next to output range. You click in that box. And then this is just the computer asking, okay, I'm gonna run a hypothesis test. Where do you want me to put the information? Okay, so the information I'm going to stick over here in cell I2. Okay, I2. Then I'll just click OK. And here we are. We have a 2-sample hypothesis test. That's what our computer just ran for us. Okay. This is the results of a 2-sample hypothesis test, t-test, 2-sample assuming unequal variance. Okay. So first we have the mean. Well, let's see. First we have the data on the U.S. Treasury 2-year, and we have data on a U.S. Treasury 10-year. Okay. This is the average price of the 2-year, the average price of the 10-year, the variance of the 2-year, the 10-year. We have 252 observations in the 2-year column. We have 252 observations in the 10-year column. Hypothesized mean difference is 0, degrees of freedom, but this is the good stuff right here, okay? T-stat, that's our test statistic, okay? Our test statistic, T-stat. Then we have a p-value for a one-tailed test. Please note, the p-value is 1.52, right, times e to the negative 143rd power. That's scientific notation. That means that this number, the number is actually 0.0000000000000, right? There's 142 zeros, 152, right? So it would be 0.000, 142 zeros, 15209. That's that p-value, okay? So this is scientific notation. You were most likely taught this before. If you forgot it, please try to refresh yourself on it, okay? This is scientific notation, times 10 to the negative exponents. It means we're getting very small decimals, okay? Here we have a critical value for a one-tailed test. So if we had a one-tailed test, this would be our critical value, 1.65. Then we have a p-value for a two-tailed test. And we have a critical value for a two-tailed test. Okay, so what type of test did we have? We had a we wanted to know if the price of the 2-year Treasury bond was the same as the price of the 10-year Treasury bond. We want to know if they were the same. So we said the null 2-year equal to 10-year, alternative 2-year not equal to 10-year. So we have a two-tailed test. Okay. If we have a two-tailed test, that means that our critical value was 1.96. As you can see right here, right? The critical value two-tailed test, 1.96. Okay, critical value 1.96. Meanwhile, our test statistic is 51. Okay, we have a test statistic of 51, but our critical value is 1.96. And then, of course, since we have a two-tailed test, it's negative 1.96 and positive 1.96. Okay, so let's go back, draw that in. So our negative critical values 1.96, and then our positive critical value is 1.96. What that's telling us that if our test statistic goes past negative 1.96 or positive 1.96, then that test statistic, right, if it goes past 1.96, it'll be in the region of rejection. Or if it goes past negative 1.96, then we'll be in the other region of rejection. Okay. Well, our test statistic was 51 point something, right? It was 51, right? So our test statistic of 51, let me just write, like, I'll write it in. That's the T stat, right? Okay, 51 is our test statistic. So that puts us, right? So the test statistic is in the region of rejection. And therefore, we reject the null hypothesis. Okay. We reject the null hypothesis. Okay. You don't have to, cross it out. I'm just doing this for effect, right? But we reject the null hypothesis. And therefore, it's unreasonable to think the 2-year is equal to the 10-year. Okay? It's unreasonable. The 2-year and the 10-year, they're not the same, right? Why? How do we know that the 2-year and the 10-year treasury bond don't have the same price? Well, pretty simple. Okay? It's pretty simple because the test statistic is 51. 51 is in the region of rejection. If the test statistic's in the region of rejection, we reject the null hypothesis. What's the null? Well, the null is that the 2-year and the 10-year are the same. Oh, wait a minute. Well, they're not the same, right? We're in the region of rejection. Therefore, we reject the null hypothesis. Correct. And if we are rejecting the null hypothesis, that means it's unreasonable to think the 2-year and the 10-year are the same. Okay. Well, how confident am I in my results? Right? How confident am I in this? Well, I'm very confident because my p-value, okay, the p-value for a two-tailed test, the p-value for a two-tailed test is 3.04 times 10 to the negative 143rd power. Okay? So it's 3.04 times 10 to the negative 143. Okay? I'm going to go write that over on the whiteboard, right? 3.04. Okay? So P is equal to 3.04 times 10 to the negative 143rd power. That's what P is. That E, the big E that you see, E negative 143, what that's saying is times 10 to the negative 143rd power. Okay? So what is this number? Well, when you see something like this, when you see times 10 to the negative 143, again, I mentioned that you've already done this in grade school, but in case you forgot it, that means that P is equal to 0.00000, keeps on going, right? It goes for 142 zeros. Okay. It goes that way, 142 zeros, 304. Right? So we could just keep filling this in. Right? So it's 0.0000000000304. Okay. Since the p-value is very, very, very small, right? P is at that point, P is basically zero. Okay. P is basically zero. Alpha was 0.05. Okay. So P is basically zero, right? I mean, it's 0.000000000, it just keeps going, 304, right? It is the p-value is 0.142 zeros, 304. That's where it is. Alpha is 0.05, so P is less than alpha, right? P is much less than alpha. It's much smaller than alpha, which means that we reject the null hypothesis, right? We reject, and we are very, very, very confident in rejecting the null hypothesis. Why? Well, let's take a look, right? Hey, let's say your boss says, I want you to find out if the 2-year treasury bond and the 10-year treasury bond have the same price. You go, oh, all right, okay, all right. Well, I want to know if the price of the 2-year treasury is the same as the price of the 10-year. So you run a two-sample hypothesis test, right? So two-sample, because we don't really care what the price is. We just want to know if the prices are the same. If you wanted to know what the price was, then you would run a one-sample hypothesis test, right? You run a one sample. But we don't care. We just want to know if the 2 and the 10-year have the same price. We don't care if that price is $5, $55, or $115. We don't care. We just want to know if they have the same price. So we ran a two-sample hypothesis test. Is the 2-year the same as the 10-year? And like I said, you could do this by hand, but it would take you about a half hour or so. You could just do it in a computer. So we did. We ended up with a critical value. We had a two-tailed test, negative 1.96 and positive 1.96. Okay? Those are the critical values. But meanwhile, the test statistic is 51, right? The test statistic is way out here at 51. That's in the region of rejection. So since the test statistic is in the region of rejection, then we will reject the null hypothesis. We reject it. We get rid of it. We say, no, 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 no. It's not correct. It's not correct. We reject the null hypothesis. And if we reject the null, right, we're in the region of rejection. So we reject the null hypothesis, which means that it's unreasonable. It's unreasonable to think that the 2-year treasury bond and the 10-year treasury bond have the same price. Okay, it's unreasonable to think that. Instead, we go with the alternative. We say, yeah, you know what? I think the 2-year is not equal to the 10-year. Okay, this one looks a lot sharper to me. So your boss says, hey, I want you to find out if the 2-year and the 10-year have the same price. And you say, oh, no, 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 they don't. They don't. I rejected the null hypothesis. The 2-year and the 10-year have different prices. And your boss says, are you sure? I'm thinking about making a huge deal that involves $50 million on it. You say, oh, okay, well, all right. Well, how confident am I? I'm very confident in my results. I absolutely do not think the 2-year and the 10-year have the same price. There's no way. Okay. I am rejecting the null hypothesis. The 2-year and the 10-year are not the same. How do I know that? Because the p-value is basically zero. Okay. The p-value is basically zero, which means that I do not have to worry about the 2-year and the 10-year having the same price, right? The p-value is basically zero, right? It's 0.00000000304. So P is less than alpha, which means that I can reject the null hypothesis. Okay. I reject the null hypothesis, And I'm very, very confident about that. I'm very confident because the p-value is basically zero. Okay. Where did I get all that from? I got it from right here, right? I got it from Excel. Okay. Again, in Excel, we have our test statistic, 51. This is the p-value for a one-tailed test. This is the critical value for a one-tailed test. If you had a one-tailed test, you would have to worry about those, but we don't, so we don't have to worry about those at the moment. We don't have one-tailed tests, we have a two-tailed test, right? So for the two-tailed test, our critical value, right? Critical value two-tail, that's 1.96. It's negative 1.96, positive 1.96. And then the p-value, like we said, was 3.04 times 10 to the negative 143. In other words, it's 0.00000000304. And therefore, not only do I reject the null hypothesis, but I am extremely, extremely, extremely confident that I can reject the null hypothesis because I'm extremely confident that the 2-year treasury bond and the 10-year treasury bond do not have the same price, right? My null hypothesis said, hey, is the 2-year and the 10-year the same? And I said, all right, I'm going to go test it. And I rejected that hypothesis. And I really, really rejected it because the p-value is basically zero. Okay. So that's honestly all there is to a two-sample hypothesis test. Okay. If we understand the 5 steps, right? The 5 steps of hypothesis testing. That's why I said they're so important, right? Step 1, null and the alternative. Step 2, level of significance. Step 3, choose your test statistic formula. Step 4, critical values. Step 5, do the test and, calculate the p-value. Okay. But as long as you understand those 5 steps, every single hypothesis test in the entire world is the same 5 steps. The only difference is if you're doing a one sample hypothesis test, you are comparing your population against a specific number, a specific value. And if you're doing a two sample hypothesis test, you're comparing your population against another second population. But you can still end up having a one-tailed test, a two-tailed test, right? A left-tailed test, a right-tailed test. You still need to figure out the level of significance, right? All those that you do the p-value, right? You could have if you have a two-tailed test, you have to multiply the p-value by 2, right? You still have degrees of freedom, the level of significance, right? One or two-tailed tests. All those things are the same. It's just how you state the null and the alternative, and then how you end up calculating it, which if we did it by hand, it'd be a little different, but honestly, you don't do this by hand. People use computers for it. So that's what you should see. Okay. So that is two sample hypothesis tests. Okay. The next lesson to then go on to would be an introduction to linear regression.